Hi, welcome to my video on extra rules with logs. One of the rules that's extra that I haven't discussed before is the rule of the log of b to the x base b equals x. Let's prove the rule using the power rule. And the power rule is that the x is the power moved in front of the log, so it's the x log of b base b. And the log of base b, the log of b base b, b to the 1 is b, so that's 1, and x times 1 is x. So anytime you have the log of, if the base here is the same as this base, then you pick the power. So let's have a look at that. So let's evaluate this in 3 different ways. One way would be that 2 to the watt power gives you 8, so the answer is 3. Another way would be let the log of 8 base 2 equal x. And that means you have base exponent number. So 2 to the x equals 2 cubed. So since the bases are the same, the exponents are equal. And another way to do it would be to take 8 and express it 2 to the 3. So 8 is 2 cubed. So we have the log of 2 cubed base 2. So since this base is 2 and the base of this exponential is 2, we get a 3. So there's 3 different ways. Let's work it out again. The log of 9 base 3. 3 to the watt power gives you 9. The answer is 2. And the log of 9, when the base is 3, is equal to x, so we let it equal x. You get, you get 3 to the x equals 9. So 3 to the x is 3 squared, so x is 2. And the third way is that let the 9 be 3 squared. Since this base is 3, the base of this exponential is 3, so the answer is 2. So we're using this rule, but we can do it different ways. So anytime you get the log of b to the x base b, then the exponent is automatic, if you wish to use that rule. Another rule that we use in logs, move the page. Another rule is the log of n base b is equal to the log of n divided by the log of b, where n is greater than 0, that's the number is greater than 0, and the base is greater than 0, not 1. But let's look at if the base is 10. So the log of n, when the base is 10, can be found using a calculator. So notice the log, you pick up your calculator that I have here, and the log of 10, well that's a 10 there. So if we hit the log button, and the base is 10, so we hit the log of 12, you will get, you can see you get 1.07918, and notice this goes on, even though it stops here, but that's an irrational number. So therefore, if you want to round it to the nearest 10, so there's 1.08. And to check that, if you want to check it, if you take 10 and raise it to the 1.08, it should give you close to 12. It won't give you exactly 12, so 10, power button is the exponent here, and it's 1.08, and you should get, did I say close to 10? Close to 12, the log of 12. So this is the base is 10, so 10 to the 1.08 gives you approximately 12.01, so it's close to, it's approximation of 12. And what about the log of 150? So the log of 150, and again the base is 10, so that's Notice if you put the base 10 here, just think about it. 10 to the watt power gives you 150. So 10 squared is 100. 10 cubed is 1,000. So this answer should be more than 2. So let's see. The answer is, again, 2.17609, dot, dot, dot. So it's approximately, rounded off to the nearest hundred, 2.18. So check 10 to the 2.18. Let's clear this. And we go 10, power button, 2.18, and we get 151. Because we rounded this higher, this is why this is not going to be 150. But the more decimal places that you can put in, the more decimal places, 2.1760, the more decimal places you put in, the closer you'll be to 150. Okay, let's continue. What about if B is, what about if B is not 10? Well, if B is not 10 and N is greater than 0, now that means we can let the log of N base B equal X. That means we can write base exponent number. So if we let this equal X, we can now change the log to an exponential. So base exponent number, so B to the X equals N. So now we can do, notice that X is in the exponent. The only way you can get to the X is to do a log. So we go log B to the X equals log N. And the power rule, X moves in front by the power rule. So log B to the X equals log N. And we divide both sides by the log of B. So X equals the log of N over log B. So notice we prove this rule here that X is log B to the N. X's log B to the N is equal to the log of N divided by the log of B. That's when the base is not 10. So the log of N base B is the same as the log of N divided by the log of B when B is not 10. And let's do some practice. Write each as the log of N divided by the log of B. So this is the log of 7 divided by the log of 2. I look at it as a 7 over 2. This is the log of 24 divided by the log of 5. So we're using the rule, the shortcut. The log of X base 4 is the same as the log of X divided by the log of 4. And this one is the log of X minus 1 divided by the log of 3. And again, just practice. So this is the log of 61 divided by the log of 6. And this is the log of 211 divided by the log of 12. So it's a rule that you keep in your mind that makes things easier to do sometimes if you remember this rule. The log of N base B is the same as the log of N divided by the log of B. Okay, now there's another rule that we can use in the log of N base B is 1 over the log of B base N. So this is N base B, this is B base N. And to have a look at that, let's look at the log of N base B. The log of N base B is the same as the log of N divided by the log of B. We just proved that one. So that's the same as 1 over, and when you do a 1, you can flip this around. So that's the log of b divided by the log of n. So 1 divided by the log of b, log of n, gives you this because you multiply by the reciprocal. And so that gives you 1 over the log of b divided by the log of n is the log of b base n. So what we did, you can use this rule too when you're doing your math. So the log of n base b is the reciprocal of the log of b base n. And let's do some extra practice. Express each as a reciprocal of the log of n base b. So this is 1 over the log of, and again, the 6 goes to the base, and the base goes to the number. And this is 1 over the log. So this is 5 goes to the base, and the base goes to the number. Express each as the log of n base b. So this is the reciprocal. So the reciprocal, this is the log. So the 9, which is the base, becomes the number, and the number becomes the base. And 1 over the log of x base, log of 2 base x is the log of x base 2. So by interchanging the number and the base, we get a reciprocal of. So that brings us to mind another proof. So I look for, in textbooks, and I look at teachers teaching this, and I come up with some extra rules. Prove that the log of n base b times the log of c base n is equal to the log of c base b. Well, let's take the left side here. This is the log of n divided by the log of b. And this is the log of c divided by the log of n. And notice that these are the same bases. The base here is 10, 10, 10, 10. So they cancel out. So that gives us the log of c over the log of b. And that becomes the log of c over the log of b. That's the log of c with the base b. So notice we prove them using the rules that we just learned. Again, we want to prove that this equals the log of c base b. Notice the log of n base b, the log of c base n, the n's cancel out, we get the log of c base b. Find the value of each. And notice we can take a shortcut. This is the log of 4 base 3. This is the log of 9 base 4. So we can think about it that the 4's cancel out. So this is the log of 9 base 3. So 3 to the what power gives you 9, so the answer is 2. And we got 1 over. 1 over is the reciprocal, so that's the log. Base here is 2 and the base here is 3. Let's flip this around. So this is the log of 2 base 6. Let's flip this one around. This is the log of 3 base 6. Now notice the two of them are the same logs. So the sum of two logs is the log of the product, base 6. And the log of 2 times 3 is 6, base 6. So what power of 6 gives you 6? And the answer is 1. Again, doing different rules, using rules, but helps you understand. Or quicker too. You got some rules that are shortcuts. They help you get to the problems much quicker. If the log of n equals x and the log of the log of n base b equals x and the log of m base b equals y, express the log of b base n times n in terms of x and y. So we have the log of n m base b. So we want the log of n base b. So we got to notice the base is here, this is in the number. So we got to flip that around. So that's 1 over log b is the base, and m times n is the number. So the reason I do that, because b is the base here, and b is the base for these two. So flipping that around, I get 1 over. Notice it's the log of a product. So a log of a product is the sum of the logs. And that becomes 1 over log of n base b. Log of n base b is x, plus the log of n base b is a y. So the log of b base n m is 1 over x plus y in terms of x and y. And we have another property to prove. So 1 over log dc base d, 1 over the log of dc base c equals 1. So we want to, let's work this side down to get the 1. So this is 1 over reciprocal. So this is the log of, put a d there, and that's a dc there. So the reciprocal is the log, and that's a c, so that becomes a number, and that becomes the base. So the reciprocal, we flip the number and the base around. Notice now that the two bases are the same. This is the sum of the logs, so the sum of the logs is the log of the product. And the base is dc. Notice the bases are the same. And so the log of dc, when the base of dc, is 1. So we took the left side and worked it down to get a 1. This side is a 1. 1 equals 1, so now we prove. We've done the proof that this expression is equal to 1. Let's continue, more practice. Find the value of each to the nearest 100. Well, I want to show you, if we want to show you this, the log of n base b is the log of n divided by the log of b. But when you do that on a calculator, you have to be, you have to use your calculator. To use your calculator, type it in this way. It's a log. Put the n in brackets. Division, log, and put the b in brackets, and hit the equal sign. Notice you got to do the log of n, put n in brackets, division, log, b in brackets, equal sign. If you do that, then everything is okay. So the log of 19 base 2. So let's just take a guess. 2 to the what power is close to 19. 2 to the 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. So this is somewhere between 4 and 5. So the shortcut, this is the log of 19 divided by the log of 2. So if you pick up your calculator and you turn it on, see if okay, you can see it. This is the log of 19. Notice, and now I hit is in brackets, and I hit divide, hit log again, and I put a 2 in a bracket, and it gives me 4.247. So that's 4. Now to the nearest 100. So notice this is irrational. So 4.2 to the nearest 100 is 4.5. So if you take the 2 and raise it to the 4.25, you should get close to 19. So let's clear that and take 2, and this is the power button right here. this calculator, Texas Instrument, and you raise it to the 4.25, and when you do, you should get close to 19. Hey. But again, because you rounded this off to 4.25, the more decimal places you could put in, then the more accurate your answer is going to be to 19. And right here, we want to do this one. This is the log of 36 divided by the log of 5. And clear it. So we got the log of 36 in brackets, division, log 5. And that gives us 2.2 to the nearest hundred is 2.23. 2.23. And if you check it, you take 5 and raise it to the 2.23. And how do you know you're okay? Well, 5 squared is 25, 5 cubed is 125. So this exponent has to be between 2 and 3. So we clear it, and we take 5, and we raise it to the 2.23. We should get close to 36, and 36.19, okay, 36.2 is close. And continue. I'm going to move the calculator now. So this is the shortcut. What is the log of 3 divided by, what's the log of 3 when the base is 7? So 7 to the watt power gives you 3. 7 to the 1 is 7. So this is below 1. So the log of 3 divided by the log of 7. And put the calculator here so you can see it. Make sure it's in the right position. Clear it. So it's the log of 3 division log 7. And I get 0.56450 rational. So to the nearest hundred is 0.56. So 0.56. And again, as a check, 7 raised to the 0.56. And I'll clear that. So 7, power button, 0.56. And I get 2.97, which is close to a 3. And this one is the log of 83 divided by the log of 4. And again, 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. So that's somewhere between a 3 and a 4. Let's see if we're right. The log of 83 division log 4. Now I'm showing you this. So notice we got 3 point, and to the nearest 100 is, again, this is irrational. If I use this answer here, so the only reason I say to the nearest 100 is to make it convenient to write down. So this is 3.19. So if I clear and I take the 4 and I raise it to the 3.19, then I should get, we have a 4 power button, 3.19, and I get 83.28, so it's close to 83, so everything is okay. Okay, so notice, but if you did this the long way, another way to do this with another way I'm going to show you down below. This is the shortcut, the log of 19 divided by the log of 2, and use your calculator. But let's find the value to 2 decimal places. 2 decimal places is the same as changing it to hundreds in 2 different ways. So I did this the short way. Now I'm going to show you 2 ways. The shortcut here, to find the log of 100 base 3, is the log of 100 divided by the log of 3. So let's use the calculator. The log of 100 division log 3 equals 4.19. to the nearest hundred. So 4.19. Again, if you use all the, if you use all those decimals, then you would have a closer answer. But we're rounding it off. So that's one way, that's a shortcut. But what about if you wrote the log of 100 base 3 is equal to x? So if I let it equal x and I solve for x, I'll get the answer. So when we do it this way, we get base exponent number. But notice when we do it this way, x is in the exponent, so I have to do the log of each side. If I do it right, log, so the log of 3 to the x is the log of 100. So x so I let it equal x. I write base exponent number, do the log of each side. Power rule, x goes in front. So now we divide by log 3. So x equals the log of 100 divided by the log of 3. So that leads us right here. So notice, if I let this equal x and rewrite it in exponential form, do the log of each side, then I'll still come to right there. Log of 100 divided by log of 3 is right there. So this is the long way, but it's nice to know if you forget this. Find the value of this one. So 4 times log of 5 base 7. So one way is to write, this is the log of 5 divided by the log of 7. So now, you can type this in your calculator, go 4 times the log of 5 divided by the log of 7, and you'll come up with an answer. Or you could use your calculator. I'm going to put the calculator up here a bit so you can see it. Okay, clear it. So if I do 4, if I do the log of 5 divided by the log of 7, log of 5 division log 7, I'll get an answer, and the answer is 0. Again, to the nearest 100. The more decimal places you write down, the more accurate your answer is going to be. Because you're rounding to the nearest 100 to keep things a little bit simple, then you're going to be a little bit off. So this is 0.83. And then you multiply that answer by 4, you get a 2. So if we take the answer, clear it, if we take 0.83 and times it by 4, you get 3.31. So changing this to base log 5 over log 7, doing a decimal for it, and then multiplying by 4, you get this answer. But if you want, there's another way. You can also do this. 4 is a power, so that's a 7, 5 to the 4th. So that's the log, base 7. 5 to the 4th is 625. So that's the log of 625 divided by the log of 7. Let's see what that, so the 4 goes to the power of 5, which is 625. So the log of 625 division log 7. And it gives you 3.3, that's a 0, that's 8, so it's 3.31. So again, a little discrepancy in the answers, but it's still close. Okay, just wanted to show you different options when you're doing this. And your teacher recognizes that which way is another way, I just thought about it, another way would be to write this down as, notice, you can plug all that in your calculator. So watch, I'm going to sub all this in my calculator. So if you went 4 times log 5, notice got to use brackets, division log 7 again, you get this answer. Very similar. So you can, many options here, as long as you do it correctly. Okay. So we got some more problems to work out. Find the value of each to the nearest 100. Okay, here we go. Notice now we have the log of 7 base 2 plus the log of 5 base 2. Because both of them are the same bases, we can say that's the log of, the sum of two logs is the log of the product. So that's 7 times 5. So that's the log of 35 when the base is 2. So that's the log of 35 divided by the log of 2. So what's the log of 35 divided log of 35 division log 2, and we get 5.13. So that's 5.13 to the nearest 100. So notice the two of these are the same bases, so we can, the sum of two logs, the log of the product. But we can't do that here. Oh, sorry, I got ahead of myself. This is, notice we're simplifying here. So this is the log of 31 base 5 plus the log of 12 base 7. But because they're different bases, I have to go the log of 31 divided by the log of 5 plus the log of 12 divided by the log of 7. So if you work this one out, the log of 31 divided by the log of 5, you get a 2.13. Just check it out. Pause your calculator and see if I'm right. See if you get the 2.13. Log of 12 divided by the log of 7 is approximately 1.28 to the nearest 100. So we got them done individually, and we add them together, we get 3.41. So check with your calculator, make sure you got 2.13 and 1. But we got to do them separately and then add the decimals. D, and we look, we got a base 3. So first of all, power rule. So this is the log of base 3 of 6 squared. Power rule. This is the log of 3, and the half goes to the power of 9. So power rule always goes first. So any number in front of a log goes up to the power. So that's the log of base 3. 6 squared is 36 plus base 3. The 9 to the half is square root of 9, which is 3. So that gives the sum of two logs is the log of the product. Notice now the bases are the same, so I can do that. Again, you can do that here because the bases are 2's, but you can't do it here. You got to do them individually. So that's 36 times 3 when the base is 3. So that's the log of 108, base is 3. So that's the log of 108 divided by the log of 3. And if you do that on your calculator, as I showed you, you should get 4.26 approximately. Now we have another one to do. The log of 8 base 2 times the log of 111 base 5. Notice we're multiplying these now. It's only when the sum of logs is a product. The sum of two logs is the log of the product. But we got a product. We can't combine these. But what's the log of 8 base 2? Well, that's a 3. 2 to the what power is 8? 3. And this is the log of 111 divided by the log of 5. So if you want to plug that in the calculator and go 3 times the log of 111 divided by the log of 5, and that will work out to be 8.78. Try your calculator, and I'll show it here, right here, just to make sure, just clear it for you. So it's a 3 times log 111 in brackets, division, log 5 within a bracket, and we should get 8.778 to the nearest hundred is 8.78. Okay, and we got one more to do. This is 2 raised to the log of 32 base 3. So this is 2. And this is the log of 32 base 3. So that's the log of 32 divided by the log of 3. So you got to be careful with your calculator now. So best thing to do, I find, you got to be careful, is to change the log of 32 divided by the log of 3 and work that out on your calculator. So when you work that out on your calculator, that comes out to be 3.15. So if you change the log of 32 base 3 to the log of 32 divided by the log of 3, that gives you 3.15. Now take your 2 to the 3.15 and you'll get 8.88. So I'll show you that now right here. There we go. So clear it just to make sure. Yep. So I'm going to do the log of 32. Division, log 3. So it gives you 3.1546, irrational number. We round it off to 100, so it's 3.15. So there's the 3.15. Now, clear it, and I take 2 and raise it to the 3.15. So 2, power button, and 3.15. And I'll get 8.876, so it's 8.88. Again, just notice I made up a little different problem here. So it tries to make the problem different to help you think. So that brings us to the end of this video, where we worked out some extra rules that's going to help you when you do logs. And if you like my video, click on the like button. If you're not a subscriber, click on the subscribe button if you wish. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.